I am Professor Juan Balmaste from the Polytechnic University of Valencia in Spain. I am the coordinator of the Satera project. Satera is a SesarJU exploratory research project focused on developing and validating the concept of a system for space-based aeronautical surveillance. This system combines ADS-B and enhanced multilateration techniques to provide surveillance in areas where ground-based systems are not available, while also enabling integrity checks for ADS-B signals. In addition to coordinating the project, we are actively involved in several of its technical activities. Finally, we will be responsible for integrating the validation platform in the near future, conducting the validation experiments, processing the results, and assessing the final maturity of the solution.
Hello, my name is Alex Canal. I'm a senior research engineer at Collins Aerospace, Ireland. Collins Aerospace is a global leader in aviation focused on advanced, intelligent, and innovative solutions that are redefining the aerospace and defense industries. We're proud to be part of the Satera project, leading the development of the system-level concept of operations and architecture for space-based composite ADS-B and enhanced multilateration surveillance system for aircraft flying over oceanic and remote areas. We're also evaluating its global economic viability for airspace deployment. We're helping define operational scenarios to support validation exercises. In processing multilateration data, we're developing an integrity indicator to benchmark positioning data before it goes to the air traffic controllers. As an aviation company, we're exploring how to efficiently leverage the solution's outcomes. We're excited to contribute to this innovative effort, supporting a safer, more secure aviation future.
Hello. In the Satera project, we contribute with our experience as a space national air navigation service provider, especially in remote and oceanic areas like the Canary Space. We're involved in work packages 1, 2, 7, and 8. In work package 2, we support the definition of operational requirements for space-based composite, ADS-B, and multilateration. We also provide real-world insights to guide the system design and expected performance. In work package 7, we help define validation scenarios, especially for oceanic and remote airspaces.
Hello, my name is Mahsa Muhebbi from University of Rome, Tor Vergata. Currently, I'm working on the research grant within a project named Satera. Our university has a long-standing heritage in GNSS, localization technologies, and radar systems for civil aviation and ADS-B systems. In Satera, we are involved in 4 work packages, leading 3 of them. In work package 3, we are designing and validating the hybrid receiver and synchronization architecture. In work package 5, we are creating a system evaluation tool to assess Satera's localization performance. In work package 6, we are developing an advanced localization algorithm. And finally, we are supporting the project's communication, dissemination, and exploitation activities in work package 8. We are proud to be a part of this journey, contributing to the security and safety in aviation.
Hi, I'm Javier Vera from the Antennas and Propagation Lab at Polytechnic University of Valencia. At APL, we design advanced millimeter wave antennas and devices, and we lead the antenna development for the LEO satellites in the Satera project. We've explored different array topologies, from plan to conical, to ensure seamless integration into the satellite. This year, we're excited to share 4 major contributions in top international conferences. Follow our work on LinkedIn and in Satera-Sesar.eu.
Hi, my name is Frederic Cerveira. I'm a professor at the University of Coimbra, and I am also a researcher at the Software and Systems Engineering Research Group of SesarJU. Our role in the Satera project is mainly in task 3.4, where we are the leaders, and we share the objective of devising new approaches to ensure that low Earth orbit satellites and the software running on it can operate correctly in the harsh environment that is space. There are existing approaches, but these increase the weight and the cost of satellites, which is not acceptable for our use case, because both weight and cost are key constraints. Therefore, we will try to devise new approaches based on software-implemented fault tolerance.
My name is Noé Godinho, and I'm a professor and researcher at the Department of Informatics Engineering of the University of Coimbra in Portugal. My research group, Network Communications and Security, is the leader of the Work Package 4 that deals with the communication networks in Satera and participates in other work packages. The goal is to ensure that messages broadcasted from the aircrafts reach a ground station within a latency constraint and a reasonable message loss. Our group focuses on two aspects: modeling and simulation of the communication networks, and analysis of the feasibility of security techniques taking into account existing constraints. Currently, we are developing several routing and security strategies to be evaluated.
Hello, my name is Victor from UPB. My work is mainly focused on WebPackage 5, where we have developed a system evaluation tool where we combine the camera lower bound from Unitop and the constellation design from IP, and we assess the performance of the whole system, as well as I've also participated in WebPackage 6, where we are developing traffic filters and the central processing station.
I am Fátima Matiello, leader of the Satera project at the Brazilian National Institute for Space Research, which develops and operates space missions, such as satellite, ground system, innovative space technology, and associated applications. In Satera, we play the role of associated partner, contributing with experts in orbital dynamics and space system engineer. We are actively involved in defining the satellite constellation and developing the constellation propagation model, which are activities related to Work Package 2 and Work Package 5. Besides collaborating with an international relevant team, our participation on Satera solution represents an opportunity to evolve its capabilities in satellite constellation operation, being unique to address challenging issues in the context of a real and complex space application in air traffic survey.
Hello everyone, my name is Antônio Prado. I work at the National Institute for Space Research in São José dos Campos, Brazil. I'm working on astrodynamics and aerospace engineering in general. I work also in the graduate school that we have here at INPE in aerospace engineering. And at this moment, I'm also working on Satera project. What I'm doing in this project is to study how to propagate orbits, which means that we need to know the position of the satellite in a given time, such that we can use those positions to calculate the position of the airplane. And also helping to define the constellations, the number of satellites, and which type of constellation we need to do. We simulated several types of constellations, and now we are choosing the best one for Satera. I believe this is a very important project, and I'm very happy to be able to work in this. Thank you.
Hi, my name is Giulio Sidoretti from the University of Rome Tor Vergata. My research group is involved in multiple work packages. I will describe the activities on Work Package 6. Within the work package, we derive the theoretical formulation for localization algorithms and multi-target tracking. Then, we provide integrity validation for multilateration data against GNSS-based ADS-B data. The next steps will be to finalize the practical implementation of the simulated system.
Main role of ENAIRE in Satera is to provide to the project the view and experience of an air navigation service provider. ENAIRE is the largest ANSP in Spain, with responsibility to manage 5 FIRs, one of them in the Canary Islands, covering oceanic airspace in the Southern Atlantic area. It is precisely in oceanic areas where we feel that Satera space-based surveillance improvements will bring more benefits. ENAIRE is interested in supporting the validation of techniques to independently validate the space-based ADS-B position, as they will hopefully will end up being implemented.
The present satellite ADS-B report allow the ATS service to provide a reduced longitudinal separation in remote and oceanic areas where we don't have radar coverage support. In fact, at present, there are some oceanic airspaces where this technology is being used to reduce the separation between aircraft at the same flight level. Now, Satera project can offer us an improvement to the ATS services for the air traffic management. The independent validation of ADS-B position through the ADS-B multilateration will provide us with a much more precise aircraft position report by having this kind of ADS-B redundancy. And by increasing the integrity and accuracy of the position report, we will increase the level of safety and will be ready for the next step in the ATS management. We'll be ready to manage the air traffic with an even better horizontal separation, even dreaming of working in the future with the same separation that we apply at present in continental airspaces where we always have the radar coverage.